Is this turn on? Let's see if I can get this up.
Yeah.
The button is, oh, there.
Okay.
Hi, can you hear me? Hi, thanks guys, thanks for coming. Okay, so I'm gonna click around here and stand here. Okay, so I want to talk about a little bit about, well, going from artificial intelligence to natural intelligence. Why I want to do this is because, I mean, not just Lovable, but a lot of companies are pitching AI this, AI that. Investors, the moment you talk to them, they say, do you have an AI? Do you have machine learning? Do you have this and that? But all of that is basically shadowing the fact that you're dealing with humans. And again, I'm saying this coming from a background of being a behavioral science and neuroscience advisor as well as an AI advisor since 2011. So I've been kind of doing this for a while for larger companies and eventually co-founded InsightGenie. So, and because I come from I wear both hats, I can see how one can kind of foreshadow or make the other one being ignored. So you've seen probably everything from hallucinations from LLMs to Twitter, Microsoft's, chatbot that was on Twitter, I think that was basically hallucinating. There's a lot of hallucination, there's a lot about language models, but everyone is not talking about the elephant in the room. The elephant in the room is when you're dealing with humans, especially now the LLMs kind of mainstreamed AI and languages, etc., language models. No one is talking, and I can tell you by the way, none of the LLMs is made with psychology or neuroscience or any kind of an actual design based on behavioral science, none of it. It's basically simple inference and induction system, which is stupid. I'm just going to be blunt about it. It works, it gives you plausible sounding responses, but there is no intelligence, no conscientiousness, nothing at all. So the challenge that we are trying to deal here with is how do you instill, and again, if you look at marketing materials or what a lot of the larger kind of both LLM providers and everyone says is, we want AI to be intelligent, and depending on who you ask, they go further. They say we want artificial general intelligence, super intelligence, and everyone has their own little definition. But again, none of them talk about the, again, elephant in the room. How do you instill AI with some sort of actual intelligence of a 6-year-old person, a kid, right? A 6-year-old kid outperforms a number of benchmark parameters compared to OpenAI that got tens of billions of dollars poured into it. How or why? Because a 6-year-old kid has what's called the world model built into his brain, not something that none of the LLMs has. LLMs have language models. They don't have world models. They are not built with specific consciousness. So the goal here is basically to give you some ideas, some triggers of thinking, not just AI this, AI that, which is very sexy and cute, but it's not sustainable and it's not the future, if you ask me. What would be the potential future, at least in theory, is when AI gets built using behavioral neurosciences, because that's where you can hope to come close to some sort of a human cognition, right? So this is probably the most important slide. It's also the most beautiful slide. Sorry, I'm being sarcastic. I drew this in my notebook. So that's existing product things, using behavioral and neuroscience insights or design principles, so normal process, normal product or application. You have a product, and then they want the product to cause people to suddenly get happy or something, and that changes the product, how people interact with it, and then comes back to the product, and hopefully there is an iteration, right? So that's part of behavioral science and neuroscience, and biology change is completely skipped. To be fair, again, one reason is because it's an unknown. People who are in AI, especially technical researchers, talk about behavioral science is like you're talking about Mars. It's a blind spot. They don't even know that they don't know, right? So what we have done, I mean, as a company, is kind of bring that back into the equation. And I think what I want to share is that this should be the actual loop of doing any AI, right? Especially when the AI deals with people. You have to do something based on human sciences, which behavioral neurosciences are. That causes normally, if you do it well, a biological change, right? Biological change, I put a couple of neurotransmitters there. Probably some of it might be familiar to you. Oxytocin, dopamine, serotonin, cortisol. There's around 50 of those. That can cause change of state of a person, so people can get happy, excited, etc., etc. And that can in turn cause how we interact. And then again, if the product team is upgrading or kind of iterating on a feedback, this can go like this. It's basically a loop. What does this slide mean? This slide means that when you're thinking of a product or a service, start from the end. What do you want the person to feel, to experience when they're using a product? And I was just giving an example, just talking here. Let's say you have a saving application. Let's say it's a savings account, right? Let's say it's a mobile application. What you want people to do is interact with it. And for anyone to interact with some financially special application or service, people have to trust it, number one, right? There could be other things, but trust. Trust can be created using oxytocin. It's even called the trust hormone or neurotransmitter. How do you create someone, how do you get someone to create in their head oxytocin? There is ways to do this. You can use either behavioral science or neurosciences. And if you instill a design with those insights that eventually create oxytocin, anyone using your application is eventually, again, assuming you've done well properly, is going to get, of course they don't know, it doesn't light bulb saying, hey, I have oxytocin created, but people are going to start trusting your application or your product or your feature. People are going to use it exactly as you want. But the point is, currently everyone is on a surface level. I want people to use my savings application. It's cute, the colors are nice, but they don't understand what's underlying it. What we're trying to say is that think and know what's underlying that process. And then once the biology changes, once this neurotransmitter is emitted in your brain, you start feeling calm, trusty, and then what that does, right? Then you start actually interacting with the product. Then you actually do what you're supposed to do, the desired actions. And again, that collects as feedback or data that can be analyzed by the product team or the tech team or whatever, and then they can do more of that or similar, or they can tweak if it doesn't work, right? When you don't see the desired result. But the idea is that you have to think from fundamentals, first principles, right? Ali was talking about Elon Musk. So think of it, what's the science that would drive the desired behavior? There is a lot of science. It's just a matter of knowing about it, knowing that there is science and knowing what it is. So you say, okay, cool, this very beautiful loop is nice. How do we action that? So let's say you want to create a product that has ML, gamification, whatever. You need to connect that to whatever the person is supposed to feel, experience, and do with your product, right? I deliberately put human biology, psychology, cognition because that's what it translates to. And you have to do three things. Understand what you want to do, how you can map whatever the features, etc. you want to do, and basically design for those, right? So this thing is kind of three stages. Understand what the people are supposed to feel, experience, etc. Map what are the relevant neuroscientific or behavioral insights that need to happen for this product to basically be doing what it is supposed to be doing. And then design for it using AI, ML, gamification, features, colors, how you structure things, right? It's relatively kind of straightforward in that sense. So behavioral science, again, behavioral science is an umbrella name, by the way. It's not a one science, right? There is different types of psychology, sociology, anthropology, all of this. Umbrella name of this is behavioral sciences, right? There's a bunch of those. And some of the most used, and you can Google this is all Googleable, things that you can put in your product from a design stage or interaction stage, etc., are some of this, right? For example, I was just sharing, anchoring and decoy effect. If you know how to, for example, you have a consumer product, you want them to choose this product over that product, etc., you can use anchor and decoy effects from psychology. If you want to have very specific way of people choosing, for example, between different, I was saying, saving products, you can use framing and choice architecture. I didn't mention here loss aversion. For example, you can use loss as a way of formulating your offering in a product because people are a lot more receptive to loss than versus a gain, right? There is even a number, roughly 2 times. If I say you're gaining $10 versus you're losing $10, even if you have $1 million in your bank account, you feel 2 times stronger about losing $10. Isn't that crazy? It's crazy, right? And the funny part is a lot of behavioral sciences are not intuitive and not common sense. You'll never know this until you study or you know how to apply. Study by yourself or in a university and you know how to apply. So I'm saying this because a couple of times when I was advising, I would get the head of marketing with 30 years of experience saying, you're saying this, I've been doing marketing, what are you going to teach me? I said, do you know any of the sciences? No. So then how are you, like, she said, yeah, but I have a common sense I experience. I said, no, you don't. This is not mathematics that you can just kind of pick up some of the basic stuff. You have to really learn. A lot of it is very counterintuitive. So using different concepts and principles, for example, from behavioral sciences, some of the most used ones are here. You can design a product that would drive a specific desired behavior, engagement, or interactivity in your product, in your service. Again, you see, I'm not using the word AI. AI could be used in conjunction. AI is basically how you will implement it, right? Or ML, etc., or how you'll analyze it. But the driving factor is not AI. AI is tech, right? Just to be very, very clear. And you can use also neuroscience. Again, depends on what, again, I'm not trying to turn you into experts, and I appreciate a lot of this could be kind of over the head, but a lot of the things, for example, from neuroscience perspective, you can like use, for example, how you do design of a UI, UX of your product, your tag, your solution. What colors do you have? As simple and banal thing like colors is going to make a difference in perception of and subsequent actions on your product. For example, and by the way, this is also culturally driven. Like if you go, for example, to Chinese applications as an example, white is a color of death. So nothing is designed with white. It's very colorful, looks like a rainbow. You come to Europe, right? You put colorful rainbow kind of thing, and people are going to be like, what is this? It's repulsive, it's too many colors. Every culture has specific ways of perceiving colors. If you know, there's even the whole discipline of neuromarketing, right? It's neuroscience marketing. It's called neuromarketing. If you can find out how it is, especially if you're in marketing or doing some technology or marketing, you can really like piggyback on actual science. We're discussing mirror neurons or neural coupling, right? If you, like mirror neurons, the idea is that if you see someone do something, similar neurons in your head trigger. Like for example, someone is eating something, I'm looking at the person, specific neural network in my head that would trigger. If I eat, triggers, even though I'm just looking at the person eating. This is not common sense. You will never know this unless you study it. How you can use it to your advantage? Many, many ways. I mean, we can discuss that separately, but the idea is that if you know it, you can trigger specific behaviors. I mean, and if you, now for a second, think for a second. I can put in my product some things that would trigger in your head specific desired biological changes. It's basically weaponizing your product, weaponizing as in psychologically weaponizing or mentally weaponizing your product to cause specific things in my head. I want you to, for example, to emit oxytocin. Then I do something in my product, you emit oxytocin. It's basically a weapon, it's a mental weapon. Obviously it can be used or abused, etc. Obviously we're advocating for a good usage, but the idea is that if you think about it, you can cause other people experience biological or cognitive change. Yeah, as a result of using your product. Isn't that a big thing? It's a big, very big thing. So again, not going one by one, but the idea is that, like for example, storytelling. A lot of you probably intuitively know that storytelling is cute and cuddly and nice, but did you know that it activates default mode network in your brain? And what that does is that it helps you in identity formation. So imagine seeing a specific story over and over again. Story becomes part of your identity. Did you know that? No. But if you know that, what can you do with it? In your technology or solution or whatever, you can build specific stories, and people will keep on coming to them without realizing it. Some of the main messages of your story become part of their identity. That's crazy too, right? So takeaway is that if you know some of the science bits, you can design a product that's not just good looking for your customers, for your segment you're going after, but it's a product that really shifts someone's biology and someone's mental states in a direction that you want. And causes, obviously, as a result of that shift, they do what you want them to do, or they behave the way you want them to behave. You can call it, as Ali was telling me earlier, manipulation. Manipulation and influence are not two different things, it's the same thing. Yeah, you influence people. Manipulation just has a bad rep because people always think you're manipulating for a wrong reason. If you manipulate a person to have healthy habits, it's a good thing, right? But again, I'm giving you a blunt, raw feedback. You can use this obviously to manipulate in whatever way you want. The idea is that you can impact someone, influence someone, or manipulate someone towards specific things. That's what it is. So that was the understanding part, right? That there is all this science. Now map, right? Second part. How many of you thought that reinforcement learning is an AI concept? Raise your hand. I'm surprised not more of you are raising your hand, because a lot of people in AI think reinforcement learning is an AI thing, and a lot of you are technical. I can tell you, reinforcement learning has nothing to do with AI. Before AI existed, since millions of years, well, hundreds of thousands of years, if you go to Homo sapiens, reinforcement learning is how humans learned. It's biological, evolutionary. When you're a kid, how do you learn a language? You start when you're like 2 years or whatever, you start saying mama, and then your mom says mama. Reinforcement learning, that's how you learn it. AI has been trying to mimic or simulate how our brain and our behaviors are. That's what AI has been doing as far as neural networks are concerned. Supervised or unsupervised learning is concerned, reinforcement learning, even generative adversarial networks are a simulation of what we already have in our systems. All of that is a simulation. I'm not saying AI is a fake. I'm just saying that a lot of what effort went to AI, that's what's called artificial intelligence, because the idea was to simulate actual natural intelligence of a human being, right? So what I did here is basically, and you can do both ways, the mapping, right? Reinforcement learning. In AI and ML, of course, it's known as trial and error. You look at what's good, you double down on that. What's bad, you get rid of it. Yeah, here is the neuroscience, behavioral science background of that, and some of the terminology and some of the phenomena. That has been known for many, many years before AI. Right? The same for supervised learning, the same for Hakobyan learning, unsupervised learning, etc. All of those, or most of those concepts that are very popular in AI are rooted in human biology, cognition, emotional management. If you know this, then you will design something, you call it AI, but it would actually be based on human science. This is the point, right? Until now, or until whatever, recently, you didn't know. But if you know, then you'll have a lot more deliberate design of your tag, your solution, etc., actually using science. Not something that was supposed to mostly basically emulate the natural intelligence. Again, not going to, I'm sure a lot of you know this, Bayesian inference, etc. Right? So this conversion stage happens once you understand, okay, I want the person to feel this for my product. Okay, now I want to have this features. That would cause the person to feel this way and act that way. And then, because you're converting between behavioral science and AI or technology, then you can implement some of those. So what's the point, right? Why did we go through all this, right? And I haven't even come to the design part properly. The idea is that AI is a technology that can scale any solution, but a lot of the current and modern AI systems, and I'm not talking about the trading or some things that are very abstract and nothing to do with humans. A lot of human-related AI, including LLMs, are basically designed to simulate or mimic our actual intelligence. You knowing the sciences of it is going to make your designs, your solutions, your technology that much more science-backed, and as a result of that, you'll actually have whatever that you're looking after. So behavioral science adds, and I always say, I'm like, you're assessing a human, you have to use human science. It's very simple. AI is only good in aggregate and averages. AI is not good at individual assessment, unless, again, AI gets rooted in some sort of biology or physiology or mental something, right? So coupling these two together, or looking at technology such as machine learning or AI from behavioral science and neuroscience perspective, is not just going to explain how to use your technology, but it's going to empower you to be very deliberate in what you want to achieve and how to do it. So my last slide is basically, okay, so I said all this, great. How do we go about this? Number one, as I said, start from the end. From day one, understand, before you even design stuff, and I know it's a bit like trivial stuff, I'm saying understand your customer, right? That's kind of common sense. Understand on a deeper level. what do you want your customer segment to do? What is that you want them to do? You are an e-commerce application, you are a savings application or technology. What is that you want them to do? What kind of feelings, and this is maybe the part that you may or may not have before this presentation. I'm not saying what they want to do. Before what they want to do, what do you want them to experience and feel when they do this? Think of it from that point first. If you get that experience and feeling part first, and you do that correctly, the doing part will follow. If you want them to trust your application, create trust. If you want them to anticipate the next step, then create something that drives dopamine, which is the anticipation drug. If you want them to feel calm and relaxed, maybe you can create something with serotonin, right? So always start with what you want them to feel experience, because that feeling and experience is what drives our behavior before logic, and it takes a higher precedent over logic, right? As you've seen by now. Then translate the desired human experiences into tech. You can map. I just showed you as an example again. You can use that, or basically Google or ask around and see how you can map that into, okay, I want, for example, the color like this, I want the structure to be this, because I want people to look here and there, because I want them to feel that. That's the end goal. And then if you do that, and with this thinking that I want them to feel this, which means I need them here, I need this here, I need that here, and I want them to click here, this is the storyline I want them to go after, that's how you're gonna think about it. If you think about it that way, everything will be a lot more efficient and you'll get the desired behaviors. I'm not promising from day one, but sooner. And then once you did this, observe. Is the desired behavior happening? If it's not happening, why do you think it's not happening? It's a hypothesis. Go back to that loop, right? Where is that loop? How do I cause biology change? And of course, you can do surveys, ask your customers, do you feel this? And you can even ask them, do you feel trust? Do you feel good? Do you feel calm? Do you feel excited? These things. And if you know these things, you can try and surmise what those things are, and then you can go back again and see what you have to do in the middle to cause that. But think of it from a more human perspective. I think that would be the way I would describe this. And obviously always, this is cliche, you all are product or tech people, you always tweak. I'm just saying tweak based on actual insights of the people, how they feel, how they experience, how they interact. Not necessarily what they do, the what comes after the how of the feeling and experience. And I think that's kind of it. So my big message, if you take nothing else, is just remember, AI has been initially, at least the human part of it, not the trading part, whatever, designed to mimic actual intelligence. Ironically enough, we forgot how actual intelligence works, and we don't know a lot of how our intelligence works. But for whatever we know, take that and use that in your own respective tech and solutions, because a lot of it is there. A lot of it is not rocket science, but it's also not intuitive and common sense. You do have to read up, learn, ask experts, then go and design based on that. That's the only way you're going to get whatever you're going to get. Otherwise, very superficial level, just, which is what probably a lot of you have seen done. Thanks a lot.
Wow, a true masterclass in how to bring science into product building. We summarize.
I don't know about true masterclass, but hopefully it triggered some thoughts on things
absolutely,
here.
Absolutely, it did. And I truly got stuck at one of your slides. I'm fascinated by this subject, but you had a slide and you emboldened emotion to bypass logic.
Oh yeah, that's the neuroscience. Yeah, so
scary.
I have to say this, and if you have any questions, feel free. I think a lot of the cases you might not know that if you can cause, so there was a research, this is actually quite a big thing, research that showed people who have their, I'm not gonna now go into technicalities, emotional centers removed, or 2/3 of emotional centers, are not able to make simple decisions, such as take the spoon to eat your food. Think about it for a second. You have the emotional part removed, you cannot decide on anything. Isn't that crazy? Emotions are always overriding logic, always. If you can create an emotion with your application or tag, forget about skepticism, logic, resistance. It's all bypassing it. So a lot of the now behavioral science effort is, the applied one is, how do I create specific type of emotion or experience? Because once you do that, people are not going to ask questions. They're going to do what you want them to do based on that emotion. So it's not a just a cute little something here. It is a big thing. You can Google emotion to bypass logic neuroscience, and you can get a lot of articles how to do that, or a lot of research.
Yeah, and it is, as you mentioned, it is also a mental weapon. It could use as such, and
it's a weapon. It's what it is. I just call it by its name.
And
it's
we well know
you can misuse it.
For sure. I'm gonna hand off the questions for you, but just one question. So we know about, let's just say, malicious applications of this, like the algorithms today in social media. That's absolutely one of them. But just instill some hope into us. Do you know of any positive applications, widespread applications?
I give you one neutral case. Again, I don't know Stockholm so well. I don't know supermarkets, but generally supermarkets or big malls. You pay attention sometimes before you enter the mall, or at the entrance you have some little something with a board with some pricing. You've probably seen this, right? Many of the cases, the pricing that's mentioned there, I'm not talking about the restaurant advertising discounts. No, generally, the price is a high price. This plays on the fact that there is what's called anchoring effect. You see a number unrelated to whatever you're going to do inside. Subconsciously, you're not even focusing. You just pause and you see there's something there. Anchoring effect is one of the most powerful things in psychology. The idea is that, and they've done a lot of research, they ask everything in a classroom of kids to working professionals and C-levels. They give a random number, then they ask a question, and people respond to, like, one school case example is very simple. They took a class of kids, and there's a lot of this, right? And you give them a random number between 1 and 100. Then the next question you ask is how many UN members exist, when they all learned how many UN members already exist. They found that people were given a small number, random number. They don't even say it's about UN or something. They give a random number, immediately after they say how many UN members. There is a strong correlation of what the number was and how many UN members, kids who knew until then, said that UN has. Literally, the lower number, the lower the UN number that they would say. Completely unrelated to numbers. I'm giving you a number, then I'm asking UN. Or I can give you a number, then I can say how many kids you have. That number is going to be determined by the anchor. Now, a lot of consumer companies use anchors without advertising. Why would they? Right? Because they want you to think that if I show a high number, you go in, everything else is going to look cheap. Subconsciously, that's how you think. And that's how they want you to think. They put some, when you pick up an insurance, they give you a big price, life insurance, and say this added bonus, and you're like, this is okay. I pay, I don't know, $5,000 for this whole life insurance every year. That tiny little thing for 200, 300, it's okay. Except up next to 5,000, all of it looks very small. If 5,000 wasn't there, the 200, 300 would make you feel like, oh, you're paying a lot of money. So there is a lot of like anchoring, contrasting, like we can decode for you. If you look around, there's a lot of behavioral science here. A lot of it is not advertised, but if you know what to look for, you'll find. Good example is about health. For example, applications that drive you to do specific things. You like when they make you say, your peers, for example, know, like, I don't even know the names now anymore. There is applications where you basically say, I'm going to do this, accountability. I'm going to, I don't know, run a marathon. And then it broadcasts to all your friends. And then you're like, shit, now I have to go and run because everyone knows about this, right? This is also behavioral science. It's called social proof. Social proof is the idea that you care about what people close to you or your family think about you. It's a science. It's not just an opinion. Because now you feel pressure to go run because you told everyone you're going to run. It's a good thing for you, right? Because application was designed to manipulate you to being healthy. Run a marathon, exercise, and all that.
I've been saying I'm going to run a marathon for 10 years now, and I still haven't. So
yeah, so there's a lot of examples of usage that, again, you say, oh yeah, of course, normal. But there's serious science behind it. And my favorite one, and I'll just say this and I'll stop. Anyone who heard of a term mere exposure effect? Okay, what is it?
It was called mere exposure bias or something.
Do you know what it is?
I think, okay, so does it work?
This is super cool.
So I kind of uncovered about this exposure bias effect when I was doing a project related to something, recommendations and stuff. So over there, I was trying to look at bias and stuff, and I kind of realized that some of the choices which like certain demographics are making is because of the exposure bias effect.
Okay, so remember that. So I'll reformulate some of what he says. Mere exposure effect is the idea that if you see something regularly and for lengths of time, without focusing on it, you're gonna like it. Think about it. It's there in your visual horizon. You constantly see something. For example, I have a 2-year-old kid. I put chess in front of him and violin when he was 2 weeks old. He has been constantly seeing it. Now he loves it. He's 2 years old. Doesn't know anything about what violin is, but he loves it because he has been seeing it for 2 years every day. If you want someone, now what does that mean for the product or tech? There's also habituation, that neutralizing factor there. But the idea is that if you want someone to like something, this could be for your kids, parents, in your tech, in your product, expose them to something regularly. They don't have to pay attention to it. That's the best part. That's what branding companies do, marketing, random, that you probably think it's a stupid application, Coca-Cola posting their advertising in a bus stop. No, it's not stupid. They expose you to that. That's why you continue buying it without even consciously realizing that you like it. That's what they do. They don't advertise saying, I'm using psychology to do this, but they do, right? So use it, and again, completely counterintuitive. Seeing something and liking it, and I'm not talking about years, couple of weeks, 1-2 months, and you like it. And you don't even know that you like it. Ali, sorry, I'll stop if you have probably other questions.
That was fantastic. I think we'll have to take a break there. And meanwhile, we have an open bar, so we can just go and order some. I know it's just Thursday, but there's a lot of cold drinks. You can order if you want, and we'll aim to start again in 10 minutes. Okay, so network, talk a little bit, and get some refreshments. And thank you again to Hayk.
Thank you.